Hi everyone, Dan here for GE Inspection Technologies, and today I'd like to demonstrate setting up a simple uh, angle beam inspection scenario using the AWS D1.1 amplitude evaluation method. So to get started, I have an IIW type 2 block here. I'm using that mainly for convenience because at one step of the process I'm going to calibrate for velocity of the material and delay of the probe using the two radii on the IIW block. When I put my angle beam probe on the block at the proper index point, I have a 2-inch radius to there and a 4-inch radius to there. So we'll use that as part of our automatic calibration process. I also have, because I'm going to be demonstrating AWS, I have a nice block here that has a number of roughly 16th inch side drilled holes at various depths in a block. So a nice big block that's convenient and easy to work with. Okay, so with that I'm going to, and I also have a basic angle beam, a benchmark probe, 2¼ megahertz on a big half moon wedge at 45 degrees. So just a nice basic setup. So what I'm going to do now is pause for a second, change my camera setup around to give you a better view of the instrument so that you can follow along more easily with the setup. All right, we're back with the camera focused more closely on the instrument. So you'll notice we're starting out at the home page. I have velocity selected right now. I've already done a calibration here, but we're going to clear that. We're going to go to mild steel shear. Since we're using an angle beam probe, we want shear velocity. This just gets us a good starting point. I've selected a range that gives me plenty of room to see the signals from the 2-inch and 4-inch radii on the IIW block. So the first thing I'm going to do is go into the back menus. I'm going to go to the eval menu. I'm going to go up here to eval mode, and we're going to select that, and we're going to step through, and we're going to select AWS D1.1 since that's the evaluation method we're interested in using. We selected that. I'm going to go to probe angle, and this is an important prerequisite for setting up AWS, and this will also help configure the instrument for things like showing the different legs of the angle beam inspection in color. But we want to come in here. I have a 45-degree probe, so we'll select that. And my part thickness right now I have, we'll just leave that at 2 inches. We're only going to be working on the couple of calibration blocks, so I'm not going to be doing multiple leg inspection here. But those are the important prerequisites to set up in the back menu. Again, we went to the eval menu. We set eval mode to AWS D1.1. We input our probe angle and part thickness. So now we go back out to the main menu. And first we're going to do an auto calibration. And what this does is it's just a basic 2-point sort of distance calibration. We're going to calibrate on the 2 radii of my IIW type 2 block, and again they're at 2 inches and 4 inches. So I'm going to come down here. I'm going to start the recording process. It says SREF1, meaning put gate A over the first indication at 2 inches. It's already there. So we record that. Now it says set up over REF2. So I'm going to increase my gate A delay to move the A gate out onto the 4-inch echo. Come down here and complete the calibration process. AutoCal complete, velocity 0.1286, and it's at the range as well. So now you notice the distance in gate A is 4 inches. If I move my gate A start back to catch the other echo, 2 inches. Okay, so at this point we're all set up for distances. Now we're going to go back down. We're going to go to the AWS menu. We're going to go up 1 to select the AWS menu. And I'm going to come over here and I'm going to select a hole on my other block, a side drilled hole that I want to use for a reference. And I'm going to peek up on that. Now I need to adjust my gain to give me about a 50% echo. The reference echo when you're setting this up needs to be 50% amplitude plus or minus 5%. So anywhere between 45 and 55%. So if I go to my gate A, I want to get gate A right over top of it. Okay, so gate A is now measuring that. And another important setup thing to note, for AWS mode to work right, you're going to need the gate. You're going to need gate A in peak mode. Okay, flank mode's not going to work. You need to be in peak mode or you'll get warnings from the AWS calculator. Okay, now that I've got the gate set up, go back to AWS D1.1, go up to the B reference, peek up again, and record the reference. And you'll notice because I already had a reference programmed in from a previous run, when I input the reference, when I did the right click to input the reference, it asked me to confirm that with a double key press. That means press these two ends of the rocker switch, press both at one time. So again, we're going to go right to record. New reference will be recorded, double key press to confirm, double key press. So right, double key press to confirm. Now, at this point, the AWS calculator is up and running. Okay, so I'm not going to go into a lot of detail on how the AWS method works. There's lots of information published on how this method works, but you'll notice I'm on the same hole. The gain to get a 50% echo matches the reference gain, more or less. The C and D are coming right in at 0 dB because I'm at the same distance and the same sensitivity. So if I go out to a deeper hole, see, I actually can peak up a little more sensitivity on that. So it gives me some attenuation on the C factor to account for the greater depth. And it tells me that that hole's actually a little bit bigger or more to natural focus because it's coming up with greater sensitivity even though it's deeper. Slide out to yet a deeper hole. And you can see how the calculator factors in the greater depth on the C factor and gives me the total calculation. So again, that's the basic setup to get the AWS D1.1 evaluation method working. So just to recap, we'll go home here. The most important thing is in the back menus. In the eval menu, I need to select AWS D1.1 as my evaluation mode, and I need to set up my probe angle. Okay, given those two things, I came back out. I used the AutoCal to set up the delay and velocity for that probe. I went to the AWS setup menu, went up one click. That gives me the AWS menu and a gate menu. I used the gate menu to situate the gate such that I could see my hole on which I wanted to calibrate. Losing coupling a little bit, so I'm not quite peaked up. But I selected the hole, I peaked up. I came to the AWS menu, I scrolled up to the B reference. Get a little more coupling on here. There we go. Peaked up on the reference echo, got that at 50%. One right click on B reference, double click to accept. And now my calculator is calibrated and running. So again, I'm Dan Groninger for GE Inspection Technologies, and this has been a quick instructional video on the AWS D1.1 method on the USM Go. I hope you find this useful, and thank you for your time.